Hello Math 200 students. Going to be going through section 1.1 in this video. It should help you be able to do your homework. So this is the textbook that we're using, an introduction to statistics in chapter 1. So the first thing we're going to do is, most of the first chapter is devoted to explaining what statistics is and giving you a set of vocabulary to use that is common to the language of statistics. So here's some definitions. I'm just going to go through these definitions and try to explain them if they need more explaining. So here's some definitions. The definition: data. Data consists of information coming from observations, counts, measurements, or responses. Information coming from observations, counts, measurements, or responses. So let's say we took everybody in the class and we measured your heights. All of those heights would be examples of data. Alright, and then we have a definition, which is the name of the class: statistics. It is the science of collecting, organizing, analyzing, and interpreting data. So you take the data, from observations, counts, measurements, responses, but then statistics actually does something with the data. Collects it. We just talked about collecting it. Organizing it, so putting it in some sort of a logical organization, like maybe highest to lowest, or groups of the same heights, or something like that. Something that might make the data kind of come alive and speak to us more, that we can see patterns in it. Analyze the data and interpret the data in order to make decisions. More definitions. Okay, there are two types of data sets. Populations and samples. It's important to distinguish these. A population is the collection of all outcomes, responses, measurements, or counts that are of interest, whereas a sample is some subset, some part of the overall population. So you can define the population in whatever way makes sense for what you're trying to study. You could maybe want to know what percent of the world is female. Maybe it's not 50%. Maybe it's a little more. Maybe it's a little less. And so you want to know, of all the humans on Earth, what percent is female. And so your whole population would be all the humans on the planet, or at least all the females on the planet. Or you could maybe just be interested in what percent of GMC students are female. In that case, the population is not the whole world. It is just all of the students at GMC. In either case, both of those are defined as the population of interest. A sample is some subset of that defined population. So if the population is the whole world, then you're going to have to get some, you're never going to be able to know everybody in the world. In fact, you're never even going to be able to know everybody at GMC, all the students at GMC. You won't ever be able to get all that information. So you're going to have to take some sample of that. So if it was of the whole world, you want to get a sample that is representative of the whole world somehow. Or if you were talking about GMC, then you want to get some sort of a sample of GMC students to study, and then extrapolate the information from the sample to make a prediction about the population, which is something we'll get into later. A sample, so let's talk more about samples, should be representative of a population so that the sample data can be used to draw conclusions about the patient. Sample data must be collected by using appropriate methods such as random sampling. When sample data are collected using an inappropriate method, the data cannot be used to draw conclusions about the population. Alright, so here's example 1. In a recent survey, 614 small business owners in the United States were asked whether they thought their company's Facebook presence was valuable. 258 of the 614 respondents said yes. Identify the population and the sample. Okay, so the population we're actually concerned about here are all of the small business owners in the United States. The sample that we are able to study are those 614 who were in our survey. So the population is all the responses, whereas the sample is the 614 business owners who responded to our survey. All right, more definitions. Parameter versus statistic. This is going to have a lot to do with what we just said. A parameter is some sort of a numerical description of a population characteristic, whereas a statistic is a numerical description of a sample characteristic. All right. The statistic versus the parameter, they can differ. All right. So distinguishing between those two, determine whether the numerical value describes a population parameter or a sample statistic, and explain your reasoning. A recent survey of approximately 400,000 employers reported that average starting salary for marketing majors is $53,400. All right, are we talking about a parameter or a statistic? All right, the question is this about an entire population, or is it about some subset of the population, some sample? Well, the survey was 400,000 employers, and even though that's a very large sample, it's still not the entire population of employers. So this is a sample, and therefore this number, this average starting salary number, is a statistic, not a parameter, because it's about the sample, not about the population. Number 2, the freshman class at a university has an average SAT math score of 514. This one may be more tricky. Okay, this is a parameter because the population is what it's talking about. It is the entire freshman class at the university. That is the population. That is the concept in question here. We want to know what is the average SAT score of all freshmen at this university, and because the university has all those numbers, this 514 is the average score of the entire population of freshmen at that university. It is not just a sample. If it said there are 10,564 freshmen at this university, of those there's a sample of 2,000 students, and the average score of the sample was 514, then it would be a statistic. But it's the entire freshman class which is in question, and we have all of that going into this average, so it is a parameter. Number 3, in a random check of 400 retail stores, the Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature. All right, what do you think about that? Is that a whole population of retail stores, or is it a sample of retail stores? It is a sample of retail stores. The 400 retail stores are a sample of a greater population. Therefore, the 34% is a statistic, not a parameter. Moving to the next page here. Okay, and here are the last two definitions in this section. Descriptive statistics and inferential statistics. These are the two major branches of statistics. Descriptive statistics is the branch of statistics that involves the organization, summarization, and display of data. Inferential statistics is the branch of statistics that involves using a sample to draw conclusions about a population. A basic tool in the study of inferential statistics is probability, which we will learn more about in Chapter 3. So descriptive statistics is a much more basic kind of statistics where you're basically just displaying the data in some sort of a meaningful way. Whereas inferential statistics takes those data, those descriptive statistics, and then uses that to draw a conclusion, to make an inference, to say something more to make a prediction based on the past, what will happen in the future, kind of thing. And that's a lot more mathematics involved in that. Example 3. Determine which part of the study represents the descriptive branch of statistics. What conclusions might be drawn from the study using inferential statistics? Okay. A large sample of men aged 48 was studied for 18 years. For unmarried men, approximately 70% were alive at age 65. For married men, 90% were alive at age 65. Okay, which part of this is the descriptive branch? Well, it's kind of like basic. It is exactly what is said in the problem. 70% alive at 65 that were unmarried, 90% alive at 65 that were married. That's just it. It is what it is. It's just stating what you found to be the case. And maybe even displaying it in some kind of a graphic like this. What conclusion might be drawn is that you might say married men tend to live longer than unmarried men. That would be drawing a conclusion about the general population of men just based on the sample that we were given. All right, number 2, in a sample of Wall Street analysts, the percentage who incorrectly forecasted high-tech earnings in a recent year was 44%. So the descriptive thing is just saying exactly what the problem says. 44% incorrectly forecasted the earnings. So, but a conclusion that might be drawn from that is that it's very hard to predict the stock market, which is why even people who do it for a living get it wrong a good percentage of the time. So that's drawing a conclusion about the entire population of things. That's drawing a more universal conclusion based on just a little piece of information that we found. And that finishes up section 1.1.